So let me check if we are live. Okay, perfect. Okay, I hope that we are live now. Yeah. Hi, hello, my dear students. Hi, hello. How are you all? So I hope that everybody is in best of their health and also, very much ready as your term to examinations are almost here. So I hope that everybody has prepared well, and I welcome you all here at Unacademy to help you in your preparations. Okay, so we are going to start some of the very amazing session to help you in your preparations and to guide you so that you can do very well in your examinations, right? Okay, so let's quickly start now. I'm Ritika, a chemistry educator on an academy. I have completed my engineering in electronics and communication and have been awarded grade A in Cambridge English USL. So I welcome you all to the very amazing session of our grade 10 an academy. Okay, ICSE board. So you know that your exams are around the corner. They are going to start very soon. So it's very important to start our preparations very seriously and to have our revision very seriously, right? So for that, we are back here bringing with us some of the amazing series, okay, of your term 2 examinations. So students, please take your pen, take your notes, and let's quickly start with our session. Now, students, there's a small request that if you want to have your homework discussion or your class notes, you can click on the link which is given to you in the description of this video. Okay, so this link, it will direct you to a Telegram channel in which we will be discussing some of the important questions and some of the important things related to your examinations. Also, you can join the official Telegram channel of Unacademy ICSE board. Okay, the link, it is provided to you in the description box. Hi Raven. Okay, I hope I pronounced it correctly. So hello, how are you? Okay. Now, first of all, students, before starting, I just want to tell you some of the very amazing things that Unacademy is up with. Okay. So the very first thing is Unacademy free live class. Okay. Now, why this class is special? Okay. So here we are having some of the very amazing features which can, enhance your learning and which can help you in your preparations a bit more. So first is you can have a live real time interaction. We have chats and emojis, of course. So you can have live interaction with your educators. Next is you can ask the questions to your educators using a question tab. So you can see a question tab over here. Okay, you can either type your question or you can even attach the image. Okay, and you can discuss the questions with your educators. After that, we also have poll option. Okay, so what is poll? Here the educators, they ask you certain questions and you are supposed to answer them according. You just need to pick out the option A, B, C, or D, whatever you think is correct. And we also have various things such as we have leaderboard over here. You can see, you can compete with your friends and you can improve your performance. Okay, so these are some of the amazing features of special live classes. Now, what are the special classes and what's the timetable? What are we doing in our special class? So on 8th February, that is tomorrow, we are going to have a poll war on hydrogen chloride. Then we are going to have organic compounds. Okay, and on 12th February, so this is a 3-day timetable that I'm showing to you, we are going to have a poll war on nomenclature. So you can see we are going to do all the topics which are important as per your term 2 examinations. So what all you can do is you just need to attend the classes, and also if it's possible, try to share the link with your friends so that maximum students can have advantage out of these classes which are absolutely free of cost, right? Now, talking about an academy subscription features. So what is an academy, and how does this plus subscription helps you? So first is you can, learn from the comfort of your home. Then you will be having the unlimited access to all the courses. That is, you can access all the course that you have signed up for. You will be taught by top educators of India at one platform, no need to go anywhere. Then also you will be having regular doubt clearing and answer writing session. So in these sessions we are having the doubt clearing session separately, answer writing session separately. And what is happening in these sessions, you are being guided on how to write answers in order to achieve maximum out of it, right? Then your syllabus, of course, it is covered exhaustively. You are under the mentorship and guidance of your educators. You receive all the study material in the PDF format. So you get all your study material in the PDF format. You also have practice tests so that you can know how much you are learning, how much you are understanding. We also have live test series and of course the batch courses. Now, apart from all these things, you also get daily practice section, you get weekly mock tests, live quizzes, daily MCQ and subjective test series. So these are some of the amazing things you are getting by subscribing for Unacademy Plus. Now, what is a request? Students, try to enroll yourself because right now, it's a crucial time. Okay, so please try to enroll yourself and have the advantages. Okay, now let's quickly start with our chapter for today, which is hydrocarbons. Okay, now today we are going to focus on the organic chemistry, and particularly we are going to study about hydrocarbons, their properties, their preparations, their general chemical properties, etc. Okay, now what are hydrocarbons? Hydro plus carbon. So hydrocarbons are those organic compounds which contain only carbon and hydrogen. Okay, and these are some of the simplest organic compounds, and these are also known as parent organic compounds. So what are hydrocarbons? The compounds which are made up only of carbon and hydrogen, and they are they are also regarded as parent hydrocarbons. Now, if I talk about the type of hydrocarbon, or how are hydrocarbons classified? So first we have okay, there we have hydrocarbons. They are classified basically into two categories. Now, can anybody tell me in the chat box what are the two categories? So these two categories are, first is aliphatic, okay, and then we have cyclic. Aliphatic hydrocarbons, these are the open chain hydrocarbons, right? There is no cycle. These are open chain. So we also call them as open chain hydrocarbons. Okay. And cyclic, these are the closed chain hydrocarbons. All right. Now, if I talk about aliphatic hydrocarbons, they are again classified into two categories. Okay, can I please get the answer in the chat box? Like, what are the two categorizations done of aliphatic compounds? All right, now if I talk about the aliphatic compounds, they are classified further into saturated and unsaturated. And the unsaturated compound, they consist of alkanes. The unsaturated compounds, they consist of alkenes and alkynes, right? So for now in your course, it is the aliphatic, that is open chain hydrocarbons. Okay. In cyclic also we have two categorization, that is alicyclic and aromatic. But right now in your term 2, you are having aliphatic hydrocarbons. Okay. Which is further categorized into saturated and unsaturated. Now today we are basically going to focus on saturated hydrocarbons, that is alkanes. In the unsaturated, as you can see, we are having two categories, alkenes and alkynes. Now let's talk about saturated hydrocarbons. So what are saturated hydrocarbons? These are the hydrocarbons which contain only a single carbon-carbon covalent bond. Now, before going on for single covalent bond or double bond, let's know a bit about covalent bond. So, can anybody tell me what do we actually mean by covalent bond? All right, let me tell you. See, there are two type of bonds, right? One is ionic and second is covalent bond. So what is covalent bond? Here, the bonding or the bonds are formed by sharing of electrons, right? So this is what is a covalent bonding all about. They don't donate or take the electron completely, they instead share the electrons. Okay, now let us see how this sharing of electron happens. For example, I am taking methane. Okay, we will be seeing how what is methane and how we have named it further in the session, but I'm just telling you how the bonding happens. So see, if I talk about methane, okay, a covalent bond is a chemical bond that involves the sharing of electron pair between atoms. Yes, correct. Okay, so this is the definition of covalent bond. Very good. Now, talking about methane, we are having one carbon and how many hydrogen? Four. Okay, so how many electrons are present in the outermost shell of carbon? We are having the atomic number of carbon is 6, right? So what is the configuration? It is 2 and 4. Now, if I draw the diagram or if I draw the dot structure, okay, so it will be, these are the 4 electrons of carbon. Okay, and if I talk about hydrogen, okay, hydrogen, they have got one electron in their shell. The atomic number is 1, so it has overall got 1 electron only. So let's arrange that. We are having these. Okay, 4, yes, correct. Now what happens? This carbon needs 4 electrons, okay, to complete its outermost shell, that is to achieve a stable electronic configuration, that is 8 electrons. And hydrogen, they need one more, that makes it 2. Okay, so what this hydrogen will be doing? It will be taking 1 electron from carbon. Similarly, all the hydrogens, they will be taking one electron from the carbon. Okay, so now you can see all the hydrogens, they have got a complete valency, they have got a stable electronic configuration. Okay, so hydrogen case is done. Now what about carbon? Carbon, it has already got 4 electrons and it needs 4 electrons more, right? So what it will be taking, it will be doing, it will be taking one electron from each of the hydrogen. Okay, now how many electrons are shared from carbon to each of hydrogen? It's one electron, right? So we can draw the bonding as a single dash. Now what does the single dash imply? Okay, you want me to explain it one more time? Sure, I'll be explaining it, just a minute. All right, so let's have it one more time. Okay, so let's begin it. Yeah, so we are having CH4. Okay, now we are having one carbon and 4 hydrogen. Okay, so carbon, it has got the atomic number of 6. That means the electronic configuration will be 2 comma 4. Okay, so I'll just show you. See, this is the nucleus, this is the first shell of carbon which has got 2 electrons, and this is the second shell of carbon which has got 4 electrons. Now, to achieve a stable electronic configuration, hi Siddhi, good afternoon. To achieve a stable electronic configuration, how many electrons are needed in the outermost shell? We need 8 electrons, okay, except hydrogen and helium, which have 2 electrons. Now, these 8 electrons, we need to satisfy this valency by sharing of electrons. Okay, now why or how is it happening? Let's see. So if I talk about the outermost shell of carbon, it is having 1, 2, 3 and 4 electrons. And hydrogen, the atomic number is 1, so electronic configuration is also 1, right? Now if I draw the hydrogens, let's say these are the hydrogen atoms. Okay, now hydrogen, it needs how many atoms? Now it is already having 1, so how many atoms does it need to achieve a stable configuration? I guess 1, right? So these hydrogen, they will be taking one electron from the carbon. Okay, so now you can see every hydrogen, it has got 2 electrons, which gives it a stable configuration. Okay, so why? It is because they need to achieve a stable configuration. They need to achieve stability. Okay, otherwise they won't be stable. Now carbon needs 8 electrons. It already has 4 electrons. Now it will be sharing 4. Now it will be taking one from each hydrogen, okay, in this way to achieve a configuration. Now see, since all the atoms, they have only shared one electron, so they will have a single bond. Okay, one electron, so one bond, one electron, one bond. Similarly with this and this. Okay, so this is the structure, and you can see everything, or every atom, every element, it is having a single bond. Why? Because they have shared only one electron. Okay, if in this place they might have shared two, then we could have a double bond, but that's not the case right now. Got it? I hope everything is clear up till here. All right, now let's move on to the next topic. Yeah, so we were studying about the covalent bonding, okay, and hydrocarbons which contain only single bond, okay, between carbon and the hydrogen. They are known as saturated hydrocarbons. Okay, I hope that is clear. Now, why are they known as saturated hydrocarbons? Can anybody tell me in the chat box? Why are they known as saturated hydrocarbons? So the reason behind they being known as saturated hydrocarbons is the valency it is satisfied by a single covalent bond. Okay, so we are having single bonds between the carbon and hydrogen or carbon, that makes it a saturated hydrocarbon. Okay, now talking about the general formula. Now, in the case of alkanes, okay, we have general formula of CnH2n plus 2. Now, what is N here? N is the number of carbon. The number of carbon atoms. Okay. For example, if I take N as 1. So, what will be my formula looking like? C into 1, H 2 into 1 plus 2. So that makes it CH4. Similarly, if I want to go for N is equal to 3, so it will be C3 H2 into 3 plus 2. That makes it C3H6 plus 2, 8. Okay, got it? How do we have the formula? All right, so I hope that is very much clear. Now let's move forward to the naming. Okay, so how does the naming occur? See, for one carbon atom we have meth. Okay, and what is the suffix of alkanes? We are having suffix as ane. Okay, now how do we write? If I am having a CH4, that is one carbon atom, so its name would be meth plus ane, and we name it as methane. Okay, now for 3 carbon atom, it is prop, and suffix will remain same. So can anybody tell me what will be the name of this compound? Okay, students, 1 minute for this. Please tell me what's the name of this compound. How will we name it? It is PROP, okay? And you can also tell me the name of this compound. C5H12. Come on, who's naming it first? 30 seconds left. Yes, correct, Siddhi. It's propane. So why prop? Because 3 carbon atoms and suffix is ane. And what's the name of C5H12? Pentane. Very good. So this is how the naming is done. I hope that is very much clear to everyone. Okay, now let's move on to the next topic, that is the sources of alkanes. Okay, now if I talk about the sources of alkanes, the principal or the main source of alkanes, it is the natural gas and petroleum. Okay, so we get alkanes from the natural gas and petroleum. The natural gas, it mainly is consisting of methane, and it has got small amounts of ethane, propane and butane. Got it? Now, next is isomerism in alkane, a very important topic. Now, what is isomerism? Can anybody please let me know the definition in the chat box? Okay, let me tell you. See, isomerism is a property in which the molecule, the formula, it will be same, but the structural formula, it will be different. Okay, for example, if I say C3H8, or I'm sorry, C4H10, I will be having same formula, but the structures, they will be a bit different. Okay, now let us see how the isomerism happens in the alkanes. So for isomerism to happen, we at least need more than 3 carbon atoms. That is 4 or more carbon atoms, they show the isomers. Okay, now how does this happen, and why only 4 or more than 4 carbon atoms show the isomers? See, if I'm having 3 carbon atoms, okay, this is the first structure. Okay, and if I go for second structure, let's say I'm putting it down, then also it is the longest chain. Okay, so only we need 4 or more than 4, because less than 4, it doesn't form any different structure. Okay, here it is a straight chain, and here also it will be the longest chain. Okay, so no isomers are possible over here. So as I told you that we at least need 4 or more than 4 carbon atoms. So we will be starting with isomers of butane. What is the molecular formula of butane? Could anybody tell me in the chat box? See, but means 4 carbon atom. Yes, what do we mean by butane? How many carbon atoms are present in the butane? Okay, so I guess we should be moving. So see, but means 4 carbons. Okay, and ane, of course, we are using it for alkane, right? Okay, now butane, the formula is C4H2n plus 2. So 2 into 4 plus 2. So that makes C4H10. Okay, so that is the molecular formula of C4H10. Okay, not CH4, it is C4H10. Okay, now if I talk about the isomers, let us see how many isomers are present in the butane. Okay, now first structure that we can have, it is 1, 2, just a minute, 3 and 4. Okay, so I have arranged all the carbon atoms in a straight line. Okay, now I have to satisfy the valencies using hydrogen. So let's say that these are the valencies. Okay, okay, so we are having 4 carbons and we are having 10 hydrogen. Okay, now what is the name of this structure? Can anybody tell me what will be the name of this structure? This structure, it will be named as N-butane or simply as butane. Why? Because N here stands for normal butane. Okay, now if I change the structure of this, okay, so this will be my first structure, and now if I want to change the structure, what I can do is, this was my first structure, this is the condensed formula, right? Okay, now this is my first structure, which is named as N-butane. Now what if I bring 1 carbon atom down? Down means, see, this is my longest chain now, and this is the carbon which I have brought down. 4 carbon atoms. Let us see if our valency is being satisfied. So here we have place for 3 hydrogen. I'll just write it H3. Then here I just have place for 1 hydrogen. again 3 hydrogen, and 3 hydrogen. Okay, now yeah, Siddhi, we are going to clear the doubt, dear. Just let us finish with the isomer part. Okay, now if I talk about this structure, what is the longest chain that I am having over here? See, if I take this chain, I will be having 2 carbon atoms. Okay, but if I go for this chain, I am having 3 carbon atoms. So of course I will be selecting this chain. Right, now see over here, in this chain, what is the group that is attached to second carbon? Can anybody tell me what is the group that is attached to second carbon? So this group, it is named as methyl. Okay, it is having 1 carbon atom, so it is named as methyl. Now methyl group, it is attached to which carbon number? Can anybody tell me? Which carbon number is methyl group attached to? I guess it's 7. So 2 methyl, and what is the name of the longest chain of the carbon atoms? So in the longest chain, we are having 3 carbon atoms. That means the chain, it has got the name propane. Okay, now this is the IUPAC name. Can you tell me what is the, yeah, okay, what is the common name of this structure? So it has got 2 names, right? As normally we also have 2 names, right? One is a pet name and one is the normal name, right? So it is the standard name, 2-methyl propane. Okay, now what is the common name that we have for this structure? Please let me know in the chat box. Yes, can anybody tell me? Okay, so here its common name, it is isobutane. Yes, correct. Okay, I'm sorry, it's isobutane. Okay, now similarly, students, can you tell me how many isomers of pentane are possible? How many isomers are possible using the pentane? Now for pentane, what is the formula? 5 carbon atoms. So C5H 2 into 5 plus 2. Okay, now what will be the formula? C5H12. Now let's see how many the structures are possible. 3. Okay, let us see if 3 are possible or not. So first structure, of course, it will be the very simple CH3, CH2, CH2, CH2 and CH3. Okay, so it has got all the single. Okay, Raven is saying 12 structures. Okay, let us see if they are possible or not. So we are having 5 carbon atoms, and how many hydrogen we are having? 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So that is the first structure, which is named as N-pentane. Okay, this is my normal structure. Its IUPAC name is pentane, and the common name it is N-pentane. Okay, now next structure is the one in which I bring 1 carbon atom down. Okay, so let's say I am having 4 carbon atoms and 1 I have brought down. Okay, now see, I'll just satisfy the valency. Here it is only 1 hydrogen which is possible. Okay, here also I am having 2 hydrogen, and here 3, and also here 3. So 3, 3, 3, 9, 10, 11 and 12. Okay, now see what is the name of this structure and how do we name it. Okay, so its common name is isopentane, correct, Siddhi? Now if I go for IUPAC name, see, this is the longest chain I am having, right? Now the group, it is attached to second carbon, and what is the group that is attached? It's methyl, right? To methyl. And what is the name of the longest carbon chain? It is 4 carbon atoms, so it will be named as 2-methyl butane, or the common name, as you told me, it is isopentane. Okay, so that is my second structure. Now if I have a third structure in which I take the 2 carbon atoms and I arrange them to a different position, let us see, it's in this way, right? And if I try to fix the valencies. Okay, so it is named, first of all, the common name, it is neopentane. Okay, and if I go for the IUPAC name, see, if I take this chain, then also I'm having 3 carbon, and if I take this chain, then also I'm having 3 carbon. So whatever chain I take, it will be having 2 methyl groups. So the IUPAC name, it will be 2 comma 2. Why? Because 2 time the methyl group is coming, and since it's 2, so we will write dimethyl, and the longest chain, it is propane. Okay, so could you tell me if any more structures are possible apart from these? Yeah, can anybody tell me? Is there any more structure which is present or which can be possible? Okay, so I guess there is no structure which is possible. Okay, so in the case of pentane, we are having a total number of 3 isomers, right? Okay, now moving forward. Okay, so Siddhi asked me the third group, right? Third butyl group, right? Now see, I'll just draw it over here to show you. So tertiary butyl, okay, so it's tertiary butyl group. Now this is formed where we are having 3 methyl here and this. So this is the third butyl group. Okay, now next is the methane. So what okay, here you could be asked a question that what is the simplest or the smallest alkane. Okay, so here your answer will be methane. Okay, now today we are going to study in detail about methane, the occurrence, the physical properties, etc. Okay, now what is methane? First of all, it is the simplest alkane which is having 1 carbon atom. Okay, now it is occurred in the at the bottom of the marshes, and it is formed because of the fermentation of cellulose by a special type of bacteria. Then all the animals whose food contains cellulose, it is also present in the air which is exhaled by them. Okay, next it is present in the coal, okay, cavities. Okay, they contain 90% of methane. Okay, and it is also known as fire dam. And at the last, we can also obtain methane by dry distillation of wood or coal. Okay, so this is how we get methane. Now talking about the structure of methane. So the structure, it is 3-dimensional, and there is a particular shape for methane which is tetrahedral shape. So if the question is asked, what is the shape of methane? Your answer will be tetrahedral. Okay. Now, see, this is the basic shape that we have for methane. Okay, somewhat this is the shape. Okay, and here the bond angles are approximately 109.5 degree. Okay, now why is this structure present for methane? See, because the electrons are present in the outermost shell. Okay, since electrons, they are having same type of charge, so as you know, like charges, they repel each other, right? So the similar charge, since they repel, so therefore it gives a kind of tetrahedron shape for methane molecule. Okay, now let's talk about the preparation of methane. In the preparation of methane, what do we need? We need a soda lime, and we need sodium acetate or sodium ethanol, one and the same thing. Okay, now what is the procedure that we are taking? First, what do we take? We take the mixture of soda lime and sodium ethanol, okay, in a glass tube which is hard enough. Okay, and then we heat it over a Bunsen burner. Okay, so this is heated. Okay, this is the basic structure. Okay, you can see that we have taken the mixture of sodium acetate and soda lime, and this mixture is being heated. Now see what are the reactions that are happening. Okay, so first of all, what's happening is, just a minute. Okay, fine. So we have taken sodium ethanoate, CH3COONA, plus soda lime. Here our catalyst is calcium oxide, and temperature we have given almost at 300 degrees Celsius. So what do we get? We get over here methane in the form of gas. Okay, and how is methane collected? It is collected by downward displacement of water. And what's the reason? Why is it collected using this method? Because it is very, slightly soluble in water, and it is lighter than air. Okay, so I hope things are clear up till here. I hope you might have understood. Now it's not just this method is possible for preparing methane. We are also having some of the other general methods for preparation of methane. Okay, now let us see what are the general methods. Okay, now what happens if I take the iodomethane or bromomethane? Okay, let's take iodomethane. So that is one alkyl group. Okay, now if I heat it using the nascent hydrogen, okay, if I'm reducing it, what I will get? I will get methane plus Hi. Similarly, this method can be used to prepare ethane also. Okay, so for ethane, what are we doing? We are just taking in the place of iodomethane, we'll take either iodoethane or bromoethane. So let's take bromoethane, that is C2H5Br, and we are following the same procedure. Okay, what we will get? We will get C2H6 plus HBr. Okay, now there is one suggestion. So whenever you go for writing the equations, okay, please make it sure to write the names of the compounds that you have taken first of all. Okay, and also write the conditions over here if there are any particular condition. Okay, so for example, why do we need to go for that? See, if I write H2O, H2O can be the steam also, it can be ice cold water also, it can be warm water also, it can be normal water also, right? So we don't know which type of water we have taken. So it's always better to write the name of the conditions and the compounds that we are taking. Okay, so here we have taken nascent hydrogen. Okay, and we have got the main product, that is ethane. Okay, similarly you could write for the above reaction also. Okay, now next is when we add water to aluminium carbide at room temperature. Okay, so we have taken aluminium carbide. Okay, and I have added water to it. Okay, the temperature is normal room temperature. So what I will get? I will be getting methane plus aluminium hydroxide as a precipitate. Okay, so these are the reactions. Now then we also have a very important reaction. Okay, that is Wood's reaction. Now what Wood's reaction says, that when we warm the methyl iodide or methyl bromide with sodium metal, okay, over here our catalyst is dry ether, we get ethane. Okay, now if I'm taking methyl iodide, so we are having CH3I, I have taken sodium metal, my catalyst is dry ether. What I will get? I will get CH3, that is ethane, plus. Now this is the Wood's reaction, and from the Wood's reaction you can have one important question, that why cannot we prepare methane using this reaction? So the main reason why cannot we prepare the methane is that Wood's reaction, it is only suitable for the compounds having even number of carbon atoms. So in methane we have one carbon atom which is odd, so that is why Wood's reaction, it is not possible. Okay, so I hope that thing is very much clear to you. Now let's talk about some of the physical properties of methane. Okay, now first of all, methane, it is a colorless gas. Okay, then it doesn't have any particular smell, so it is also odorless. Next is, it is not soluble in water, so we can say that it is negligibly, okay, I'm sorry, just a minute. Yeah, so it is negligibly soluble in water. And what is it soluble very well in? So it is very well soluble in the organic solvent. So we can say that it is soluble in organic solvents like ether, chloroform, etc. Okay, so these are some of the general physical properties of methane. Next, if I go for the chemical properties of methane, so first is the methane and ethane, they are saturated hydrocarbons, so they generally do not react with the bases, okay, or with oxidizing or reducing agents, okay, but they undergo the combustion reaction. Now let us see how do they undergo combustion reaction. There are two type of combustion reactions that can happen. First one is complete combustion. Now complete combustion means they are having a good amount of air or oxygen supply. Okay, so if I take methane, okay, and if I'm having a good supply of oxygen, what it will give out? It will be giving out carbon dioxide plus water plus a good amount of heat. Now this becomes your answer for the reason why the methane or alkanes, especially methane and ethane, they are used as fuel, because on complete combustion they give out a good amount of heat. Next is when we have insufficient supply of air. So in the insufficient supply of oxygen or air, they undergo incomplete combustion. Okay, so we have here incomplete combustion. Now what happens and what is formed over here? So if I have taken methane, okay, and if there is this insufficient supply, I will be getting the products as carbon monoxide and water. Okay, so in the place of carbon dioxide, we now have carbon monoxide. Hope that is clear. Next is the substitution reaction. So substitution means what? That the place is taken by some other compound or some other element. Okay, so the alkanes, they react with chlorine, bromine, or iodine. Okay, and they substitute. Now how does the substitution occurs? Let us see. If I'm taking the reaction between CH4 plus Cl2. The condition that I need to have here is diffused sunlight. Okay, so I'll just draw the diagram to show you. So this is my methane, okay, and it reacts with chlorine. Okay, the conditions are diffused sunlight, and how are we getting it? Okay, Anubhav Singh, ma'am, I got 89% in semester exam. Okay, very well. Congratulations, many, many congratulations, Anubhav. And please try to, do much well in your next exams. Okay, so all the very best for your examinations. And once again, many, many congratulations. Okay, so here we are having methane and chlorine. So what is happening if I'm giving here diffused sunlight? This HCl, it gets removed. Okay, it gets removed, and what do we have in our hand? Now we have a chlorine substituted product, that is CH3Cl plus HCl, and this product, it is named as dichloromethane. Okay, so I got 94%. Again, many congratulations. All the very best for your preparations. Please do well, and very congratulations. Okay, all right. So we had now chloromethane, that is CH3Cl plus HCl. Again, this, it undergoes the same reaction. The conditions are same, diffused sunlight. Now what happens? Again, HCl gets removed. Okay, that is chlorine. I'm sorry. Yeah, so Cl2. Again, one H gets removed. Okay, now what we will have over here? We will be having dichloromethane, that is CH2Cl2 plus HCl. Now what is it? It is dichloromethane. Now this reaction again, it takes place. Okay, it reacts further. So from dichloromethane, we get again Cl2. So that is CHCl3, that is trichloromethane. It is also known as chloroform. Okay, so we can also name it as chloroform. And then we have the final reaction. It's CCl4 plus HCl. Now here the reaction stops. Okay, so we are having over here carbon tetrachloride, or it is known as tetrachloromethane. Okay, so this is the final or the end product that we have. Okay, now the ethane, it also reacts with chlorine in the same way. Okay, so we are having ethane, that is C2H6, and when it reacts with chlorine, at the last we have got hexachloroethane, where this reaction ceases. Okay, so I hope that you might have understood this thing also. Next is catalytic oxidation of alcohols. So when we give a controlled oxidation or catalytic oxidation, the alkanes, they will be either giving alcohol or aldehyde or carboxylic acid. Now that actually depends on what condition are we giving to them. Okay, now if I'm taking, I'll just show you how the conditions change the products. Okay, so if I'm taking methane, okay, and oxygen, okay, and the ratio over here, it is 9:1 by volume. Okay, now over here my conditions are, I am providing the temperature of 475 Kelvin, then passing it through copper tube. The pressure is 120 atmosphere. What I will be getting? I will be getting methanol. Okay, so that is methanol. So please remember, if we are having copper tube, the mixture is being passed over copper tube, we will be getting alcohol. Okay, from alkane, that is from methane, we get methanol. Now, if I change the condition, that is, if I'm taking methane, okay, and the oxidation is happening, but the catalyst, it is molybdenum oxide. Okay, so we are having molybdenum oxide. I will be getting formaldehyde, that is aldehyde plus water, so that is methanol. Okay, so from alkane we are getting aldehyde over molybdenum oxide. Okay, next if I change the condition again, if I am taking methane and oxidizing it, the condition over here is, now the catalyst is a manganese compound. I will be getting an acid, that is the formic acid, okay, plus water. So here it is formic or methanoic acid. Okay, so if we are using the copper tube, we get methanol. If we are using molybdenum oxide, we get methanol, that is aldehyde. And if I'm using manganese compound, I am getting the acid. Okay, so as the conditions are changing, we are having different products. Correct? And at the last is slow combustion. So when we are treating methane or ethane with oxidizing agent, the conditions are low temperature and high pressure. We are getting different substances. Okay. Now let us see what are the products that we are having. Here we are either taking potassium dichromate. Just a minute. So first we are having alkane. Okay. Now if we are oxidizing it using potassium dichromate, we first get alcohol. Okay. On further oxidation, we get aldehyde. Okay. On further oxidation using the same agents, we get a carboxylic acid, and at the last we get carbon dioxide and water. Okay, so that is the condition. Now let us see how is it happening. Let's suppose I have taken methane. Okay, if I am oxidizing it, okay, I will be getting methyl alcohol. Further oxidation, I will be getting aldehyde, that is methanol. Okay, formaldehyde. On further oxidation, I will be getting acid, carboxylic acid, and on further oxidation I will be getting what? I will be getting carbon dioxide plus water. Okay, so what we can do, we can just mention the compounds. That's very well. So methane, from methane we got the methanol or methyl alcohol. Then we got what? We got formaldehyde, that is an aldehyde. Okay, so I'll just write formaldehyde. Okay, then I got what? Acid, so that is formic acid, and at the last I got carbon dioxide and water, and here the reaction ceased. Okay, so other alkanes, they will also be forming the products accordingly. Okay, from ethane will get ethanol, okay, ethanoic acid, etc, etc. Okay, now next is the uses. So methane, first of all, it is source of carbon monoxide and hydrogen through incomplete combustion, right? Next, it is used to prepare some of the very useful compounds like ethine or methanol or methanol, chloromethane, tetrachloromethane, etc. And it is also used as domestic fuel. Next, ethane, it is again used to prepare the compounds accordingly: ethene, ethanol, ethanol, ethanoic acid, etc. It is used to form ethyl chloride. Now, this is used to make tetraethyl lead. And there is a solvent that is used for dry cleaning, that is 1,1,1 trichloroethane. Okay, and also it is used as a fuel. Now, a very important announcement for all the learners of grade 7 to 12. So, Unacademy is again back with Prodigy Test. Okay, you can win the scholarship and prizes while testing your knowledge in mental ability. You can enroll yourself now for free of cost, and now it's already 7th of February, so the test is scheduled to happen on 13th of February. For more details, you can click on the link in the description. So students, the test, it is scheduled for grade 7 to 8 on 13 February 12 noon, and for 9 to 12 also 12 noon. So please make sure that you attend this test. It is absolutely free of cost. Kindly go take this opportunity, because you are going to win exciting reward in every test. Okay, so you can win a 20 lakh college grant. You can get a MacBook Air, Apple iPhone, Apple iPad, Amazon Echo Dot vouchers, etc, etc. Okay, so if you are having a rank in 1 to 10, you will be also getting scholarships. Okay, 10 to 25, you will be getting 75% scholarship, 26 to 100 50% scholarship, rank 101 to 225% scholarship, and rank 100 201 to 515% scholarship. So you are getting much amazing prizes. So kindly make sure that you enroll yourself and you take this test on 13th of February from 12 to 1 p.m. Okay, next is the batch courses. So it's going to start from today, that is 7th of February. Okay, it is ACERS all subject batch in English. Now here we will be covering some of the very important aspects of your term 2 examinations. Kindly make sure that you do not miss out these batches. All you need to do is you need to enroll yourself into the sessions. Okay, and trust me students, you are going to gain very much. You will be getting the answer writing session, the doubt session. Okay, you will be getting the important questions and practice sessions. So kindly make sure that you enroll yourself in these batches and you achieve maximum out of it. Now, please subscribe to the channel of Unacademy, and if you need the PDF, you can download it using the description box link. Okay, let's quickly revise what are the things that we have learned today. We learned about hydrocarbons. Okay, so we are having hydrocarbons basically, which are of two types, aliphatic and cyclic. Aliphatic, they are open chain compounds. Cyclic, they are closed compounds. In aliphatic, we learned that there are two hydrocarbons, two types of hydrocarbons, saturated and unsaturated. In saturated, we had alkane. In unsaturated, we had alkenes and alkynes. Now, what are alkanes? The compounds which are having a single bond. Okay, they just have a single bond between the carbon carbon atoms. Okay, now after that we learned about the structure of methane, that is tetrahedron. Okay, then we learned about some of the methods of preparation of methane and ethane. We learned about Wood's reaction. We learned about some of the important physical properties and the chemical properties. Okay, so I hope that you might have understood everything that we have covered today. Kindly make sure that you download the Unacademy Learner app, okay, and you see or you watch all the special classes, and also try to enroll yourself into the batches, because you will be gaining the maximum advantage by enrolling yourself into the batches. Okay, for any more information, you can join me on my Telegram channel. The link is provided to you in the description box. Okay, so you will be getting regular updates on the Telegram channel. Kindly do not forget to subscribe to it. Okay, and also press the bell icon over here at Unacademy channel so that you get regular updates of the sessions that go on here. All right, so we will be meeting in the next session. Till then, students, please keep learning, keep studying. All the very best for your examination preparation. Let's meet in the next class. Thank you.